Hi, I'm Zixuan. I'm going to show the EE533 LAB3 demo. And first, I copy the bus merge Verilog, and the Verilog is just combined two bus to a bigger bus. And then I draw the schematic of the detect 7 bytes here. As you can see. Sorry. As you can see, I draw the schematic of word match, recognize the bytes, and the bus merge. First, we can see the how the recognize bytes schematic. This is the flip-flop, so it's really easy. This is the symbol in the system. And then we can see here is the bus merge, and he wants to combine these bytes together to a larger bus. I'll tell the reason later. And for the word match, it want to uh, detect if the 112 bytes contains the 56 bits. Sorry, 112 bits contains the 56 bits. It won't detect this. And I can show this symbol here. Uh, it split the 112 bits to 56 bits. And here, this means from the first byte to 7 byte. And this is from the second byte to 8 byte. So at the last, this is the last case. And it means he wants to detect if we have this number in this number. This uh, Here it want to detect if the this data contains this data. And the wild card means if you want to detect it exactly. Like if I can show the symbol of the comparator. As you can see here, if you want if you don't care about these bits, you can let the A mask 2 as 0, and then the output is always 1. So it means we don't care about these bytes. And in the comparator 8, it's just a compare logic. I remember it is XOR. Sorry, it counts to zoom in the symbol, but it is actually is the uh, XOR, and then will be a NOR to detect it. Sorry, this is symbol O. I made something wrong here. I don't know what's the reason of I can't see the comparator age. Sorry, wait a minute. I'll restart it. Maybe there is something wrong. And you can see here, it's just the it's not XOR, it's an XOR. And with the and and you can use the XOR with OR and an inverter to do the same function. And this is the detect 7 bytes. I had told all of the components of it, and I'll say the reason of why we want to combine these two bus. As we can see, it want to combine the uh 37 47 to 0 and with the 16 3 to 0. Yes. And actually our bus is from 100 and sorry. Actually our total bus is from 71 to 0. So it's total 8 bytes. So if you want to detect 7 bytes in the 8 bytes, it has only two cases. First case is from 1 bytes, from the first byte to 7 bytes. And the second is from 2 bytes to 8 bytes. After that, you can't detect it because we don't have more cases. And so it want to get the less uh, bytes from 16 to 0, total 6 bytes. It want to combine the 6 bytes with the newer 8 bytes. And then it can detect all the cases here with the number after it. Like we can detect the 7 bytes with one more here, 6 bytes here. It's sorry, this is total 47, 6 bytes. And then is the 8 bytes. So like the here, 1, 2, 3. we can detect all these 7 bytes and then these 7 bytes. In the same way, at the last, we can detect these 7 bytes. Oh, sorry, I draw wrong. At last, we can detect these bytes and list all the cases in our data. So after that, we can detect the only these 7 bytes. And then here. So if you want to detect more of the lower bytes, you need to add more data here at after that. So that's the reason you want why the bus merge need to work here. And this is the about detect 7 bytes. And for the job, this is the schematic for the job FIFO. And the uh, what this work is it will the IPS will um, the IDS will check the payload of each package as a continuous byte stream, and if the pattern match the position by detect 7 bytes in the payload, and the package will market it as a match. So it will give a drop a signal here, and the drop FIFO will drop all uh, this package, and if it didn't get a drop signal, then it will forward the package normally. And I'll tell the function of the two comparator. So this is the main main function in the symbol. And we can see this is the first word signal, and this is the last word signal. It will log the first word address and the last word address here. Uh, and the comparator will always to compare the read address with this line. If this line is first address, it means uh you can't read, and after if this output is last word address, it means you can read now. Also, it will also depends on the job package signal. And if the job package signal is 1, and this will get reset at the first address, like if this output or this input of CBHCLE, and it also get the job package signal, and the input is first word address, and then here will be a set. Here will be reset. Also, if here is the last word address, then uh, then it will always work, and if the symbol didn't get the if the job people didn't get the job package signal, and it will always work, and then uh deliver the data. And then I also the simulator of the IDS. This is the results, and we can see here it has the outputs, and all the outputs are red. That's all the what I did in the EE533 LAB3. Thanks.